So I am hoping that you have seen the questions. The questions were from control system subject. We are preparing for the BEL EAT examination and the other competitive examinations, that is BARC Staff Entry Trainee, ISRO Technical Assistant, all these examinations. So for the diploma examinations, the control system is not a very important subject as compared to the other subjects, but you should be at least knowing the basics. So I've tried to include only the basic questions, more theory questions in this video because we know that for diploma exams, the generally control system questions will be very less, or at least 2 or 3 questions will be there. That too from the very basics only. Okay. So if you are interested in studying the control system whole subject, topic wise video is created, that is put in the separate playlist called control system playlist. Please to watch that playlist. Okay. All the important topics I've covered in that video or in that playlist. Different videos are there actually for different topics. Okay. So now we are going to see the solutions one by one. The first question is, feedback can cause a system that is originally stable to become dash. A stable, B unstable, C conditionally stable, D either stable or unstable. Okay. Now, depending on the nature of the feedback, it can be stable or unstable. General case for negative feedback, it will be more stable. Then negative feedback means the system will be more stable. Positive feedback means the system generally it is unstable. This is a general case. It can have a lot of variations also, but generally if it is a negative feedback, the system will be more stable. Then if it is a positive feedback, the system will be unstable. Now here the nature of feedback is not given. Based on the feedback, or feedback can cause a system which is stable to be either more stable or unstable. Okay. Correct answer is D. That will actually depend on the nature of feedback. And this is the general scenario for the positive and negative feedbacks. Okay. So first question, correct answer is option D. Next question. Second question. The closed system has higher dash than the open loop system. This implies increased speed of response. So for a closed loop system, it is having more A gain, B bandwidth, C frequency, D speed. So we cannot say for gain. It actually depends on various factors. But the bandwidth will be more for a closed system. So closed system means there will be an initial system, there is an input, there is an output, there is a feedback connected, right? So this is the closed system. So for a closed system, it will be anyway having more bandwidth consumption than the open loop. Correct answer is B, bandwidth. Okay. Next question. We have done a separate video on open loop and closed loop control systems. It is given in the control system playlist. Okay. Third question. The output of the feedback control system must be a function of dash. So I'm going to draw the same figure once again. So this is a system. There is an input, there is an output, there is a feedback. I'm just writing it as FB. Okay. This is input, this is output. So the output of a feedback control system is a function of what all things? A, reference input, B, reference output, C, output and feedback signal, D, input and feedback signal. Okay. So the output of a system, here the question is regarding the output, right? So the output will be depending on, clearly you can see 2 things are connected to the system, right? What all things are there? There is an input connected, there is a feedback connected. So the output will be depending on these 2 things. First one is input, then the feedback. Okay. So correct answer is D, which is input and feedback signal. D is the correct answer. Okay. Next question. These are the basic questions from open loop and closed loop control system. Okay, next question is question number 4. So for the question number 4, a linear time invariant system is stable LTI systems. Okay, so we have done a separate video on LTI systems and its properties. So a LTI system is stable if dash. System is excited by a bounded input. The output is also bounded. Or it is B, in the absence of input, output tends to be 0. And the option C is both A and B. Option D, system is excited by bounded input and output is not bounded. So a system is said to be stable, that is an LTI system is said to be stable if you are giving a bounded input, and you are getting a bounded output. And also if you are giving no input, when input is equal to 0, then output should be equal to 0. That is, when there is no input, input is not equal to 0, input is not given, then output should be equal to 0. So these are the two cases for an LTI system to be stable. Okay. Correct answer is C. At least these two things should be satisfied. Okay. Correct answer is C. Now, if you want to study the properties of LTI system, it is given in the control system playlist. Okay. Correct answer is C. Next question. The fifth question. Fifth question is, stability of a system implies that dash. The options are, small changes in the system input does not result in the large change in the system output. Yes, that is correct. So when a system is stable means, if you are making a very small change in input, it is not getting affected with the output because the system is in the stable state. That is correct option. Option B, small changes in the system parameters does not result in a large changes in the output. That is, if you are making any small changes in the parameters of the system, the output is not much affected. That is also correct. C, small changes in the initial condition does not result in a large change in the system output. That is also correct. So correct answer is D. That is, when the system is in stable state, if you are changing the input with very small amount, or if you are changing the system parameters in very small amount, or if the initial conditions are changed, then there is not a very big change or a very large change in the output. If the system is stable means, if you are making at least very small changes, it won't affect in the output. But when the system is unstable, if you are making any very small change, it will affect the output majorly. So the correct answer is D here. Sixth question. The question is actually based from the Routh-Hurwitz criteria. So we have actually studied how to write the Routh table and how to find the stability conditions from the Routh table, all those things. Okay. So that has been uploaded as a separate video. So here the necessary conditions of stability are, the coefficient of the characteristic equation must be real and has same sign. Yes, that is a necessary condition. Then B, the coefficient of the characteristic equation must be non-zero. So these two conditions should be satisfied from the Routh table. Okay. So when you draw the Routh table, the necessary conditions should be the characteristic equations, that is coefficients of the first two conditions. That is, before actually looking into the Routh table, actually we have to look for the necessary conditions. Then we look to the sufficient conditions in the Routh table, right? So the necessary conditions are, the characteristic equations must be real. The equations must be real. That is the coefficients of the characteristic equation. So we'll have a characteristic equation, right? So the characteristic equation, we say it is G of S, H of S. So this G of S, H of S equation, which is a characteristic equation, the coefficient of this characteristic equations, it will be written in plus plus. Likewise, okay, the coefficients should be real. First one is, it should be real, and also they should have same sign. Even though I put plus, it should have same sign. This is the first condition, which is a necessary condition. Then second condition is that the coefficients should be all non-zero. That is, if you are writing a characteristic equation, consider that you are writing a third order characteristic equation. There should be the zeroth term should be there, first term, second term, and then third term. All the terms should be there. So all coefficients should be present. No coefficients should be zero. So these two cases are the necessary conditions for stability. Okay. Then we make a Routh table and then we look for the sufficient conditions. Okay. Necessary condition is there, sufficient condition is there. So all these things I have done a separate video. Okay. So sixth question, correct answer is C, that is both A and B, both of the mentioned. Okay. Next question. That is the seventh question. Seventh question is, consider the following statement regarding route harvest criteria. Okay. So, route harvest criteria, which statement is correct? It gives absolute stability. It gives the gain and phase margin. C. It gives the number of routes lying on the right half of the S-plane. Then D. It gives gain, phase margin and number of routes. The correct answer is D. It is actually talking about the gain, phase and the routes which are lying on the right half of the S-plane. Okay, so that is route harvest criteria. D. D is the correct answer. Okay. Eighth question. Which principle specifies the relation between the enclosure of poles and zeros by S-plane and the encirclements in the Q of S plane? So, we generally say it as G of S, H of S plane. So, the encirclements or enclosure in the S plane and G of S, H of S plane, it is actually based on the Nyquist criteria. Okay, Nyquist criteria, from the basic to the advanced, we have done a separate video. So according to this Nyquist criteria, there is a relationship made between the S plane and G of S, H of S plane. And based on the number of enclosures in the S plane, it is mapped to the G of S, H of S plane, and we then consider the stability. Okay, so here this relation, that is, which principle states the relationship between enclosure of poles and zeros in S-plane contour and in the encirclements of origin. Encirclements of origin means that this is the origin. Okay, how many encirclements are there for the G of S, H of S plane contour? Okay, and this relation is called a argument principle or argument relation. Okay, so this is argument principle. Correct answer is A. So again, there is a separate video on Nyquist criteria. I've actually talked very detail about the encirclements, enclosures, and the relation between S plane and G of S, H of S plane, all these things. Anyway, this principle is called argument principle. Okay. A system is said to be dash if it is possible to transfer the system state from any initial state to be desired to any desired state in a finite interval. Okay, so the correct answer is controllable. That is, if a system is transferred from any state to a given state, means to whichever state we want, if we can take the system, it is called a controllable system. Correct answer is A. Okay. Next question. That is a 10th question. 10th question is, a system is said to be dash if every state can be completely identified by measurements of the outputs at the finite interval. So if we can clearly understand and identify and study every stage of a system, it is called an observable system. So these are the two definitions, controllable and observable. So controllability means if we can take the system from any state to our required state, whichever state is of our interest, then it is called a controllable system. If we can clearly see every state of the system, and if every state is identifiable and understandable, then it is called observable system. Okay, so these are the two types of systems which we talk on the stability basis. Okay, so this is controllability and observability. Correct answer here is B. Okay. So in this video, we have seen at least we have seen only very basic areas and topics and questions connected with the control systems. So if you found the video useful, please do give it a thumbs up. Also share it with your friends. And if you want more videos, please do subscribe to the channel. Thanks for watching and keep on watching.